All right, section 3.5. This is the last section of our course. Solving equations and inequalities with absolute value. Objective, solve equations with absolute value and solve inequalities also with absolute value. Make sure you check out the videos that are contained in this module, Khan Academy videos. For a greater than 0, an algebraic expression x and an algebraic expression x, the absolute value of some number x is equal to a. All right. Now he tells me that this x could have been a positive a. The absolute value of something positive remains positive. But we know this. If we have an absolute value of a negative number, we make it positive. So absolute value problems have two answers. All right. One is a negative and one is equal to a positive. And then you go ahead and you solve it if it's a more advanced type of an equation. We'll see. But this starts out real easy. If the absolute value of some number x is 5, then we know that x could have been negative 5. The absolute value of a negative 5 is 5. Or x could have been positive 5. The absolute value of a positive number remains positive. Recall, absolute value refers to how far that value is away from the origin. It refers to distance, and distance is always a positive value. All right, I travel from my house to Boston. I travel 50 miles. Now, coming back from Boston to back home, I live in a cushion. It's not a negative 50, right? Distance is always a positive number. So absolute value is related to distance. Distance is always positive. Absolute value refers to how far a value is from the origin, positive. Solutions are negative and positive 5. Note that negative 5 and positive 5 are both 5 units away from the origin on the number line. All right, distance positive number. All right, a little more complicated. Here's the deal here. What you first got to do before you start talking about negative and positive, you've got to isolate the absolute value part of the example by itself, which means you got to get rid of this negative one. I'm going to get rid of it by adding one on both sides, or simply taking add one on both sides, or simply take that one and bring it onto the other side of the equation. All right, if I add one on both sides, I'll bring this over as a positive. 1 and 4 more equals 5. Now, the absolute value of x minus 3 equals 5. X minus 3 could have been negative 5, but because it was enclosed in absolute value symbols, I had to make it positive. Or maybe x minus 3 was positive 5 all along. The absolute value of a positive 5 is just that, 5. So two cases to consider. One when this thing in the inside of the absolute value was negative 5, and one where this guy was equal to positive 5. Solving each one, um, this one works out to be x equals minus 2. Notice when you check it, minus 2 minus 3 is minus 5. The absolute value of minus 5 is positive 5. If x is equal to 8, well, 8 minus 3 is 5. The absolute value of a positive 5 is just that. Point being is when you have absolute values, equalities, you're going to get two answers. All right. And he goes back and I believe he checks these. He goes back to the original. He substitutes in place of x negative 2 and solving it 4 equals 4, true statement. Therefore, negative 2 is a solution. He checks out 8. 8 minus 3 is 5. Absolute value 5 is 5. 5 minus 4 equals 4. 4 equals 4, true statement. So we know that the two solutions are correct, negative 2 and positive 8. All right, so that's absolute value equalities. Now it gets a little trickier because now we're talking about absolute value inequalities. All right, very important. Have this slide in your notes. If we have the absolute value of some number is less than a, that translates to that number is between negative a and positive a. If you have a greater than situation, or even a greater than or equal to for that matter, you separate this. X is less than negative a, or x is bigger than a. So this part makes sense. This is a part that's a little different. You reverse the inequality and um, you use a negative. You introduce a negative. All right. So make sure this is in your notes. Kind of important. I'll go through this obviously when I go through the homework. The voiceover. Once again, if the absolute value of x is less than 3, it's equivalent to x is between negative and positive 3. If the absolute value of y is bigger than 1, that translates to y is less than. We're reversing this and using the negative, or just drop the absolute value symbol and just rewrite what you see here. All right, so something like 2x plus 3 less than. Well, less than, I use the negative on the left and I use the positive on the right, and I solve the inequality. All right, solving graph. All right, so this is a less than, which is the easiest one. -5 on the left, positive on the right. I'm going to start off by subtracting 2 all the way across. All right, -5 minus 2 is -7. A minus, if I subtracted 2 here, the 2's will cancel out. 5 subtract 2 is 3. And now I'm going to divide everything through by 3. I got a set of all x such that x is between -7/3 and +1. All right. And a way of writing this is in set notation, and this is interval notation between -7/3 and 1. Notice the parentheses because of the strict inequalities here, which translate to a parenthesis. And here we've been seeing this since I started the slide. Here's the graph of the solution. Now, the greater than, these are the tougher two ones, all right? All right, the greater thans. So this translates to what's inside of the absolute value. You reverse this, less than or equal to, and you use the negative of the number. Or you just simply repeat what you see, you drop the absolute value. I'm going to solve this, I'm going to solve that. Here I'm going to subtract 5 on both sides and then divide through by a negative. Remembering now, when you divide through by a negative, the direction of the inequality reverses itself. Once again, here, subtracting 5 on both sides, dividing by -2 reverses the inequality. So I get values of x that are x, set of all x such that x is less than 2, or my values of x could be greater than or equal to 3. So notice, these are not strict inequalities. That's why I have brackets here, because of the less than or equal to and the greater than. So all the values to the left of 2 and all the values to the right of 3. And here you see me doing it in interval notation. All of these values union with all of these values bigger than 3, from 3 all the way out to infinity, and from negative infinity all the way to 2. And that's it. Here again, I'll do, when I start doing, watch the videos and then start the homework. If you need to, you may want to even kind of watch the solution if you're having any difficulty with the problem. So hope that helps. Hope that helps.